Hello everyone, this is Dr. Asif from the Department of Geography, Jamia Millia Islamia, New Delhi. I am working here in the capacity of assistant professor guest, and today we are going to discuss a module titled Integration of GIS GPS and its application in Earth Science Resource Management. Before going to discuss the module, I would like to explain the things which are there in the module. Because first we need to understand what is GIS, what is GPS, and what is integration, and basically what is Earth resource management or Earth system sciences. We need to understand first all these things because before going to understand all these things, it's very difficult for you people to understand what is this module about. It's very difficult for you to understand what is this module. So we need to understand all these things separately first, and then we will discuss the integration of GIS and GPS. First of all, I would like to explain you what is integration. Integration is nothing but it is the interchangeable use of different disciplines. In this case, we are talking about the integration of GIS and GPS. You all know that separately GIS will not produce such wonderful results which it can produce with the assemblage or with the integration with GPS. With the help of this technology, with the help of the interaction, we are able to achieve our goals in order to get the sustainable development, in order to get the better resource management on the surface of Earth. When we talk about the Earth system science, what is Earth system science? First we need to understand the Earth system science. Earth system science is nothing but it is a dynamic interaction between different spheres on the surface of Earth. It is a dynamic interaction of different spheres like hydrosphere, like biosphere, like atmosphere on the surface of Earth and their subsystems. Subsystems, say for example, what are subsystems? Subsystems, for example, we can say that electromagnetic radiation, we can say electromagnetic radiation, different atmospheric gases like carbon dioxide, nitrogen, oxygen, water vapor, dust particles form the subsystem of the atmosphere. Earth system science also includes the human interaction with these subspheres. It also includes the human interaction with these subspheres. Earth system science basically look at the Earth's surface as a holistic, as one holistic view, as in terms of holistic view. It does not follow the disciplinary boundary. It does not follow the disciplinary boundary. It basically try to analyze the physical, chemical, biological and human interaction happening on the surface of Earth and its relationship with the present, past and the future. Earth system science basically provide us a platform for the understanding for the understanding of the surface of Earth. It provides us, it helps us in maintaining the resource, it helps us in maintaining the different spheres found on the surface of Earth, and with the help of the Earth system science we are able to achieve better sustainable goals for the future generation. Now we will talk about what is GIS in detail. You all know that in the last few decades, during the last few decades, the development of technology lead to the development of the acquisition of spatial data in several ways. So when we talk about the GIS, GIS is nothing but it is one of the tool which analyze, process and present the spatial data GIS is basically a computer based program, and it helps in storage management, analysis and display of spatial data. GIS basically requires the coordinate system on the surface of Earth. Geographic information contains either explicit geographic reference such as latitude and longitude or national grid coordinates, or an implicit reference such as an address, postal code or road name. These geographic references help in locating features on the face of Earth. Now I would like to tell you about the GIS layer. Geographical information systems work in different GIS layers. You already heard about the topographical sheet. As you know that all the informations in topographical sheets contains in a single sheet. You know that all the information, whether it is about the railways, where it is about the roads, where it is whether it is about the location of different peaks, whether it is about the location of different canals, all the informations are together clubbed on a single sheet. But when we talk about the GIS layer, it is different from topo sheet in a sense that in GIS layers, different information which are having similar characteristics is stored in different layers. Say for example, we can say the information about the natural vegetation, their growth, their distribution can be stored in a single layer, and then we can talk about the distribution of human phenomena. Say for example, the population distribution, sex ratio, all these things can be stored in a different layers. Moreover, we can say that the different data layers of GIS can be manipulated in other layers so that we can get the new information. Now we will discuss the different components of GIS. The important components of GIS are: number one, technology component. It is clear from the preceding paragraph that the GIS is a computer based analysis system. The actual machinery is called hardware and instructions are called software. Hardware is composed of central processing unit. It tells the computer what is central processing unit. It tells the computer what to do and control the peripheral equipments. Hardware is also composed of data storage. Data are stored on a hard disk of varying capacity. A hard disk usually contains of several platters, read-write heads, axis arm and spindle motor. Besides this, data are also stored in secondary storage media such as compact disc, optical disc, pen drive, flash drive, etc. The other important component of hardware is binary system. It is very important in computer technology or in GIS and remote sensing. In computing, digital is a synonyms with binary because the computer processes the information coded as binary as combination of binary digit. 1 bit represent 2 values, 2 bit 4 values, 8 bit 256 values and so on. The value that fall between the two numbers are represented on either the lower or the higher of the two. Binary numbers are closely related to digital electronics. In digital electronics, 1 means the current electricity is present and 0 means it is not present. Bit is an abbreviation for binary digit, the smallest unit of information in a digital world. Bit are the building blocks for all the information processing that goes in the digital electronics and computers. Byte is a unit of information built from the bits. 1 byte equals 8 bit. The value that a byte can take range between 0 and 255. This means that a byte can represent 256 possible states. Now we will discuss what is software. The computer requires instruction from the operator to perform the desired work. The set of instructions are known as program. If a number of set of instructions are combined to perform number of related operations, it is known as software. Software can be classified into two basic categories. Number one, system software, or we can call it operating system. Operating system is necessary for the use and control of a computer. Its main function is to provide user interface and manage the computer resources such as memory, disk, driver and printer. Operating system may be single user or multi-user depending upon the need of the individual or organization. Some common operating system are Windows, Macintosh, Disk Operating System, Uniplex Information and Computing System, etc. The second is application software, that is GIS software. GIS software develops on the hybrid approach wherein graphical and attribute data can be handled separately and linked through the proprietary interface. Environmental System Research Incorporated, that is ISRI, is the market leader of GIS software for the last 40 years. ISRI overhauled their software package into an interportable model called ArcGIS. It is a its use a generic approach that is not application specific but allow addressing any geographic application. The other popular software available nowadays are ArcView, AutoCAD Map, GRASS, ADIS, GeoSmart, Multimedia, GeoMedia, etc. We were discussing the components of GIS. The first component I have told you about the first component, that is technological component. In technological component we discuss the computer hardware and the computer software. Software can be classified into two categories. One is program software and second is application software. Now the second important component of GIS is data component. As you know, data is the key component of GIS. Data can be collected collected or create in-house or can be purchased from a commercial data provider. Some of the example of the data are, like we need the data for the for the municipal boundaries, we need the data for the watersheds, we need data for traffic flow, we need data for rail lines, etc. So these are the data which are very useful for the GIS. The third important component of GIS is the pupil component. Pupil component in GIS were recognized as an important component only after 1990, when ISRI for the first time realized it and incorporated in their definition. The pupil in GIS can be classified as general user and GIS specialist. The general users are usually concerned with the application of the software for the specific purpose and include planners, scientists, academicians, administrators, etc. On the other hand, specialists work as programmers, system analysts, etc. So we have discussed the different components of GIS. I have told you about the three important components of GIS. Now the second important aspect of our module is the GPS. Now we will try to define the GPS. What is GPS? The full form of GPS is Global Positioning System. The Global Positioning System is a satellite-based radio navigation system which provides precise three-dimensional position in terms of latitudes, longitudes and heights coordinates of any place, point on the globe. So we can say that it is a technology which provides us the exact location of a place or point on the surface of Earth. We can get the information with the help of the GPS. We can get the information in all weather conditions, day and night and throughout the year, with the help of a handheld GPS instrument called receiver. Receiver is just like a mobile phone. The space-based program was, this GPS or space-based program was first developed by the Department of Defense, United States of America way back in 1973 for the military purposes. This program was basically developed for the military purposes initially, but later on the government of United States of America made it available for the civilian purposes too. Now we will discuss the basic working concept of GPS. All GPS satellites constantly transmit radio signals. You know that very well. The moment which we switch on the GPS receiver, it picks up signals coming from GPS satellites through receiver's antenna and process it using inbuilt software. The GPS receiver compares the time of a signal was transmitted by a satellite with the time it is received. The time difference tells the GPS receiver how far a satellite is. With the distance measurement from a few more satellites, the receiver can determine the user's position and can display it on the receiver's screen. A GPS receiver must get the signal from at least 3 satellites to get the 2-dimensional position, and if we want to get a 3-dimensional position, then we require the signals from at least the 4 satellites. Without getting the signals from the 4 satellites, we are unable to determine the 3D position of a particular place or person. Therefore, minimum 4 satellites are needed to find out the coordinates of a place on the Earth. Signals from more satellites increase the position accuracy. Now I will tell you about the GPS satellite constellations. The Navistar GPS of United States of America is the only system which provides information throughout the world. This system consists of 24 satellites. Out of 24 satellites, 21 are active and 3 are active sphere. They all are placed in near circular orbit at an altitude of 20,200 km. These satellites are arranged in 6 circular orbit planes which are labeled A to F. These are inclined at an angle of 55 degree. These satellites have 12 hours period so that at least 4 satellites are available for observation on the ground, sea and in the air at any time throughout the year anywhere in the world. These satellites are traveling at the speed of 7,000 miles per hour and powered by the solar energy. Now I would like to tell about the GPS signals. Each GPS satellite constantly transmits two low power microwave radio signals known as L1 and L2. Each code consists of a stream of binary digit. For example, 0 and 1 known as bit. P code is used for military purposes, but it was available to all users until January 1994. But after that, P code encrypted by adding an unknown W code. The resultant code is known as the Y code. This encryption technically is known as anti-spoofing. The civilian GPS uses the L1 carrier frequency of 1575.42 MHz in UHF band and L2 frequency of 1227.60 MHz. Now I will tell you about the different components of Global Positioning System or GPS. There are three important components of GPS. The first and the foremost important component of GPS is the space component, or we can call it space segment. The space segments consist of all satellites in orbit. These satellites are grouped into three subgroups according to their development and launch. They are classified into three blocks. The block 1 says there are 1 to 11 satellites and are classified as the research and developmental satellites. These satellites were launched during 1978 to 1985 and were placed in two orbital planes. These were initially launched for a period of 5 years but can last longer. Block 2 satellites are known as production and operational satellites. They were launched in the year of 1989 with a lifetime of 7 years. Block 2 are the third block satellite known as Block 2 R satellites. These are also known as replacement satellites. When there is any malfunctioning in the Block 2 satellites, so with the help of the Block 3 satellites, we are able to replace the Block 2 satellites. A GPS satellite weighs approximately 9,000 kg and it is 17 feet across with the solar panel which are extended on both sides of the satellites. These satellites are also equipped with the power backup batteries to keep them running when there is no sunshine, particularly during the period of solar eclipse. The second important component or segment of GPS is the ground control system. There is one master ground control system at Falcon Air Base in Colorado and 4 subsystems located at Hawaiian Island in the Pacific Ocean, Kwajalein Island in the Pacific Ocean, Ascension Island in the Atlantic Ocean and Diego Garcia Island in the Indian Ocean. These 4 substations are used for the transmitting the information back to the satellites. All the data from tracking stations are transmitted to the master control station located at Falcon Air Base in Colorado, where the information processed and analyzed. The master control station is also responsible for the daily management and control of GPS satellite. The third and the most important segment of GPS is the user segment. It is the ultimate and the most important segment of GPS. Any person who uses GPS tracking system to receive GPS signals for any project work is included in user segment. Appropriate GPS receiver is required to use the GPS signals for navigation and specific positioning. The figure 6 explains the 3 segments of GPS. The first segment which I am showing you is the space segment, and these 3 segments are basically interconnected and interrelated to each other. As arrow shows that space segment is related to the user segment, and space segment is related to the ground control segment, and ground control system is related to the user segment. So we can say that these 3 systems were together and interrelated with each other. Now I have already explained you about the GIS, GPS, what is GIS, what is GPS, and what is integration of GIS and GPS. Now we will discuss the integration of GIS and GPS in a little bit better manner, in a detailed manner. The purpose of geographical inquiry is to examine the relationship among different geographical features collectively to describe the real world phenomena. Geographical information system helps to analyze geographic data collected through global positioning system in almost unlimited fashion. GIS analysis uses the geographical properties of features collected through GPS to look for the pattern and trends of different features located on the face of the earth. A spatial analysis technique is an attempt to initiate what concerns human mind, that is, to create an understandable image of the real world. GIS provides the tool which can analyze the spatial phenomena in a logical sequence to develop models for future planning. These models may reveal new or previous unidentified relationship within and between different data sets. It certainly will increase our understanding of the real world. With the passage of time, GPS are becoming very effective tool for the GIS data capture. The GIS user community benefit from the use of GPS for the location data applicable in various GIS applications. The GPS can be easily linked to a laptop in the field, and with the help of appropriate GIS software, user can easily convert the data into information and can take the necessary action accordingly. GPS can be very helpful in accurate and timely GIS database. This figure shows the integration of GIS and GPS. With the help of this figure, we are able to understand how the how the integration of GIS and GPS work, and how it is helpful in maintaining the advanced travel information system. You know, this figure shows that GPS receives the data in real time, and that data is transmitted to the GIS software, and with the help of the GIS software we digitize, say for example we digitize the different data. Say for example we digitize the road map, and with the help of the digitization of data we are able to identify the dynamic route guides, we are able to identify the automatic vehicle location, we are able to identify or calculate the travel time. The above 7 figure show the figure 7 show the advanced traveler information system through the integration of GPS GIS, which is helpful in real time vehicle tracking. The mapping of GPS data is helpful in identifying the positioning of the vehicle and determine if the vehicle is on or off the road. Now I will tell you about the application of the integration of GPS GIS in Earth system sciences. As it has already been mentioned in the already been explained to you that Earth system science look at the Earth as an integrated system. It is the study of the dynamic interaction between different spheres of the Earth and their subsystem. Physical, chemical, biological characteristics of the Earth and cultural characteristics of the human being fall under the purview of Earth system science, and therefore the application of GPS GIS can be identified in countless fields. Few of them can be discussed as follows. The application of GIS GPS integration in natural resource management. The GPS GIS is taking the natural resource management by storm. The data collected through GPS can be processed in GIS environment to map our natural resources. Over the past few years, these technologies have been used to locate natural forest, sensitive plants population, plants growth, raptor nesting sites, vegetation mapping, and permanent monitoring points are now the part of GIS database available to the resource professional. The second important application of integration of GIS GPS in Earth system sciences is in the surveying and mapping. The high precision GPS carrier together with appropriate GIS software can provide adequate tool for a variety of surveying and mapping. Using DGPS techniques, accurate and timely mapping of almost anything can be carried out. The GPS GIS is used to map road alignment, environmental hazards such as landslides, forest fire or oil spills. Cadastral mapping, needing a high degree of accuracy, also carried out by using high-speed GPS receiver. Previously, cadastral mapping was done using conventional method which were time taken and requires extensive traveling. Now many government as well as the private agencies are using GPS GIS for cadastral mapping, mainly because it is time saving and cost effective. Now the use of number third is use of GPS GIS in navigation. Once we know our location, we can of course find out where we are on a map. GPS mapping and navigation is perhaps the most well known of all the GPS applications. Using the GPS coordinates, appropriate GIS software can perform all the tasks for locating the unit to find a route or selecting the best route in real time. Use of GPS GIS application in crustal mapping. Geodetic mapping and other control survey can be carried out effectively by using high-grade GPS equipments. After 1990, the GPS techniques reached a level where millimeter level accuracy become achievable globally. In geophysics, GPS measurements have been used to monitor and map the crystal displacements since last 3 or 4 decades. Use of GIS GPS application in agriculture. GPS GIS technology is used to locate and map the areas of high weeds, disease and pest infection. GPS is helpful in soil mapping, allowing the farmers to develop the contour maps showing fertility variations throughout the field. For certain precise agriculture applications such as crop planting or topographical map generation, sub-meter DGPS accuracy is not enough. In such cases, centimeter level solution using real-time kinematic can give greater accuracy as well as huge saving in time and money. As you all know that Department of Defense of United States of America developed the GPS technology for military purposes. When our soldiers are operating in enemy's territory, it is very difficult for him to get a location because he is unaware about the different features located in enemy's territory. So with the help of the GPS receiver, the soldier will able to identify his location and can find out a route to move in different parts of different territories. Also, with the help of the GPS, also for the military purposes, we need accurate and updated maps. Accurate and updated maps are required for the military purposes in a sense that military uses these maps to monitor the different locations on different parts of the earth or in different parts of the enemy's territory. Now I will discuss the use of GPS GIS in urban utilities. As you all know, the world is modernizing. The world is getting modern day by day. And if we will move in certain places which are unknown to us, in certain cities which are unknown to us, and we want to find out the location of different shops, the location of coffee house, the location of transport network system, if we want to identify the location of bus stop, then with the help of the GPS and GIS technology, we can easily find out all these things in a city which is unknown to us. GPS and GIS can be also very helpful in fleet management or in the management of the transportation system of a city like Delhi. Previously, you all know that the transportation system of a city is being maintained manually. Traffic controller posted in different parts of the cities and they manage the traffic. But with the help of the GPS, GIS technique, we can get the real-time data and we can analyze and process that data in GIS environment and can get the instantaneous result so that we can maintain the route, we can maintain the traffic on the route with the help of this GPS and GIS integration. So dear students, we have gone through the full module of integration of GIS and GPS. You all know that we have discussed the application of integration of GIS, GPS in various various problems which we are facing on the surface of Earth. With the help of the integration of these two technologies, we are able to solve many problems which human being is facing in the 21st century. Dear students, if you will go through this complete module, then definitely it will be helpful for you to understanding the technology like GIS, GPS and its integration, a role of its integration in the development of various resources found on the surface of Earth. If we will try to integrate, if we will understand the integration of GIS, GPS, then definitely we will be able to solve many problems faced by the human community in the 21st century. So with this, we would like to conclude that integration of GIS and GPS is very much helpful as far as the analysis and the solving the problem of human being is concerned. With this, I would like to say thank you all. Thank you very much.